Now I will show you how to create a Modbus server and Modbus client in the D2000. We will use XML import to import the configuration of several prepared D2000 objects. By importing a line, a station, and several IoTag objects, we will create a Modbus server listening on a TCP port 502. Then we will use a Modbus client application QModmaster that I downloaded from the internet to connect to our Modbus server and verify that we have data. We will read 10 registers starting from address 0, and we will see the changing values. In fact, I can run the QModmaster right now and try to connect to port 502 of my computer. As you can see, there is a failure, so the connection failed. Right now nothing is listening on TCP port 502. Okay, so let's get back to CNF and when we display processes, you can see that some of them have the current value run, so they are running. They are automatically started by the kernel when it is started. When I, for example, open the configuration of self.com, that's the communication process, on the third tab, parameters, I see that com.exe binary is configured, and that you can see also that auto start is enabled and the com is started as a service under the system account. So now that we have something to connect to, let me show you XML import. I'll go to my prepared directory, select all the objects that are available and click import. I will import the 14 files. That's it. I imported all of my objects. Now I can go to QModmaster and repeat my test. Can I connect to the port 502? Okay, no error now. And I can start scanning, that is reading the data. So here are my 10 registers, and I can see different values, and they are changing every second. When I refresh the list of objects, you will see that the com process gets brackets. Yeah, it's displayed in brackets. That means it has some children. I imported children for this process. The D2000 has a hierarchy. The com process is parent of communication lines. A line is a parent of stations, and a station is parent of IoTags. An object which has children is displayed in brackets. I can use this down arrow or press Alt and double click to get to the children. So I can see there is a line Modbus server, and again it is in brackets, so I can go to its children, and there is a station Modbus server, and again there are 10 children named Modbus server 00 to 09. I can click on these columns and display the address of the IoTag. So I see the addresses are 3.0, 3.1 up to 3.9. That means this specific address for a Modbus protocol, that the function 3, that is read holding registers, can be used to read those IoTags, and the register addresses are 0, 1, 2 up to 9. Next, we will use CNF, the config tool, to manually create a communication line, a station, and IoTags, which will be communicating to our Modbus server. This way we will create a Modbus client communication. Values of the server IO tags will be read by our client IO tag. I intentionally made it this way so that you can play with our configuration at home, or even if you don't have any real PLC with Modbus, so that we are both the server and client of Modbus. We don't even have to turn off the QMod master Modbus client, so the two communication will be in parallel, because our Modbus server can handle multiple TCP clients. So let's get back to the CNF tool, and we will start with a line. So I'll go to the lines, click new object icon, and I will create a line. Let's name it Modbus client. You can notice that objects in D2000 have some prefix and suffix. This is configurable, and so the prefix for line is L. So from the name I can often know what kind of object it is. I will leave self.com as parent, as we have not defined any other COM process yet. But however, in the practice we could have multiple COM processes running if we needed to. So I will click the create button, and now the configuration dialog has several tabs. The first one is common for all object types. We'll skip the groups for now and go to the line parameters. As our Modbus server is on a TCP line, here we also have to select a TCP/IP TCP line. In practice, you could have a Modbus RTU on a serial line. In this case, I would select a serial line here. The next tab depends on the line category. For a TCP line, I can define host and a port. As our Modbus is on the same COM process, I can select localhost or any of my IP addresses. In fact, I can even write multiple IP addresses now. For example, I could specify localhost and 127.0.0.1. So when the COM process tries to connect to the Modbus server, it will cycle between or among all the specified addresses. As our Modbus server listens on a standard port 502, I will specify it here. And the line number is not used in this protocol. You can specify arbitrary number 0, 1, whatever. In the protocol parameters, we won't change anything for now. We'll save and close the line. Now I can click the accept filter to display our newly created line. We see it is not in brackets, so it doesn't have any children yet. Let's create some. I can recycle this dialog, change the object type to station, and select the parent, my newly created Modbus client. I'll click the create button. Now again, there is a common general properties tab where we could add the description, for example. On the parameters tab, we have to select the communication protocols. All the protocols available on a TCP line are mentioned here or listed here, as we have a demo license. So I'll select the Modbus client protocol. Here on this tab we could also enable simulation or disable the communication for this station. On time parameters, we will configure how often the IO tags will be polled. Let's set it to 1 second. It is good for us. The next step is address. We'll configure a Modbus address of 1, as that is the address of our Modbus server. In the last tab, multiple protocol parameters can be set, but for now we'll leave auto defaults and save the station. You can notice here that the station goes to station communication error, well, because there are no IO tags to read. So let's create one. Again, we can recycle the new object dialog, but change the type to IO tag, change the name to Modbus client 00, for example, and select the parent. I'll be again using my newly created Modbus client. When I create the object, the general properties tab is more interesting now. First, we will set the value type. Let it be the analog input, not the digital. Let's keep to the address tab and set the address to 3.0. That means, again, the register 0 will be read by the Modbus function 3, which is read holding registers. Now, by default, the register, that is 2 bytes, will be interpreted as a signed integer number. We can change this address to U 3.0 to interpret the number as an unsigned integer. The format of address for Modbus protocol is, of course, documented in our online documentation. So these 2 bytes will be interpreted as unsigned number. I can save the object, and I can see I have the value 20,000, 22,000. So the COM process, we've just online reconfigured the COM process, created communication line, station, and IO tag, and the communication is running. Now, I'll close the create object dialog, refresh the list of lines. I will go to the station and go to the created IO tag. Actually, I could go directly by clicking here, but in the production I would get a list of hundreds of IO tags, and this way, when I go to the children, I have only those that are belonging to the specific line and station. Otherwise, I would have to use the mask, for example, Modbus client asterisk. Okay, now I want to create 9 more IO tags. I'll select my first tag and again click the Create New Object button. I will change the name to Modbus client 01 and click Use Sample. So I will copy the configuration of the Modbus client 00. I will change only the address to 01, and I'll also check this checkbox that when I click Save, the configuration dialog is closed. Now I will create another. I will not be using mouse. I will only the keyboard. So you can see the work can be pretty fast. If I had more objects to create, I would not do it this way. I would probably use XML export and import, or CSV import and export and import to multiply the objects. Okay, I got all my objects created. I can click refresh and I see the objects, their addresses, and their current values and timestamps now. What's next? Now let's look at the values. We see that the values are changing every second, and also that the values are different for all tags. How did we do it? Let's select the IO tags and show the configuration of all the client and server tags here. You can see they have the same values, 26, 27, changing approximately twice a second. So how do we get from this number to these numbers? This number is the same for all these are different. Let's look at them. and their configuration. This is one object and another, and let's put it next to each other. So these are our Modbus server objects. First, on the output control tab, we see that there is some user variable u.sec as a control object for both or all of these Modbus server tags. So that explains why they have the same value here. But how do we get to these different values? Well, there is another tab, conversion, and here you can notice that there is a linear conversion for both Modbus server tags. However, we have the same A parameter and a differing B parameter. This conversion is from the Modbus or the protocol values to technical units, to internal representation in D2000. So when a value comes in, it is multiplied by 0.001 in both cases, but in this case 0.2 is subtracted. This conversion is for input direction, as I mentioned. So when we write the value into this point and it goes out to the Modbus communication, the conversion is inversed. First, 0.2 is added here to the value, and then the result is multiplied by 1000. So we can say the written value is multiplied by 1000 and 200 is added in this case. For this point, 0 is added. So this is how we get from the same value of control object to a different value read by D2000 or Modbus QModMaster client. The question you might ask is, who changes this user variable? I'll close the configuration and show you the object dependencies window. So when I click on my Modbus server 02, I want to see what objects are used statically, that's in configuration, by this object. Of course, I see that the u.sec, the user variable, is used by this object. Now I want to see who uses this object. So no big surprise, all my 10 server IO tags are using it, but there is something else. It's an event, it's a script which is using it. So I can select it, I click the edit icon, and now I am editing or viewing the script written in ESL language. Well, it's a pretty trivial one. There is a begin and end, there is a loop and end loop, and in this loop we are incrementing the value of the user variable, and when the value reaches 59, we set it back to 0, so it's kind of second. However, there is a 500 millisecond delay, so we are changing it actually twice a second approximately. So this was a simple script. Now let's try to make a test. Let's go to the stations. Let's edit our Modbus client station, and let's go back to the IO tag so that we see the objects are and the values are changing. And here, let's disable the communication. You see the values of Modbus server objects are changing, and so are the changing values here in Modbus QModMaster. So the server communication is working. However, our Modbus client stopped polling the values, so the values are stopped. When we unclick the disabled communication, again the communication continues, and we have the same numbers in our D2000 system as the QModMaster sees. Now imagine that these values represent the immediate power, and we want to add these two numbers. How do we do it in D2000? We go to evaluated tags. We'll create a new evaluated tag. Well, let's call it sum of 0, 0 and 0, 1. You see the parent is a calculation process. We'll click create. And here in the calculation, I can write the object names or I can select the objects clicking on the button. I'll go to IO tags, select the first one. Okay, I can copy and modify it. I'll click the save. I got an error, a value type, missing value type. So on the first step, let's say I want to the result to be an analog. Okay, and here I got my evaluated tag, which is adding the current power of the first two IO tags. I could configure a periodic calculation, for example, every 3 seconds. Yeah, so the value changes every 3 seconds. Or select external trigger, some change of some external object. By default, a calculation is triggered by a change of any variable used in this expression. Also, sometimes when you have many objects, it is useful to limit recalculations, for example, to 1 every 2 seconds. Well, this is the end of my presentation. However, I sincerely hope it is not an end of your work with IPES of the 2000 system. Quite the opposite, it should be the beginning of your exploration of the 2000 system. Please bear in mind that what I showed you today is just a small fragment of the 2000 capabilities. So don't hesitate to use our online documentation, and if you can't find the answer here, you can contact us via email or ask on our community forum.